Hi, I'm Rebecca. I am Senior Principal Engineer at Atlassian. I lead the internal developer productivity program to make lives better for our engineers across the world. Luckily, she made the joke for me, so I don't have to introduce the doctor.
Hi, I'm Maurits. I'm the principal data scientist working on the developer productivity space at Atlassian. All data science matters. So I assume this is the clicker. Let's see if this works.
Yeah.
Does not. Let's try the old-fashioned way. Right. So, hi, welcome. We're very excited to be here. We're from Atlassian. You may not know the company so well, but you most definitely have heard about our products. We unleash the potential of every team through products such as Jira, Confluence, Trello, Bitbucket, to name our flagship products. And this is still not working. In case you didn't know, we're an Australian company. Our headquarters are in Sydney, just on the east coast of this star of the Southern Cross. I flew in from Australia just a couple of days ago, and in fact we're so Australian that we've discovered that Australian weather drives Australian Atlassian developer productivity. I know it's a bold claim. We heard about weather in Seattle and snowfall, I think in one of the sessions yesterday. This is our version. And this is a bold claim. You don't believe me? Let me show you the evidence. So take a moment to take this in. This is a bit of a complex plot. Don't worry about it. I'll take you through it. I'm showing you two graphs here, a black one and a red one. Let's talk about the black one first. This is our developer productivity satisfaction score that we're measuring by surveying our engineers every month. And in this case, we did this in 2023. And, you see a percentage and the curve goes up and there's a peak sometime in June, July, August, our winter in Australia. And in red, I'm showing you the outside temperature in beautiful Perth. Perth, Western Australia, known for, I found out yesterday.
Heath Ledger.
Heath Ledger, that's right. Heath Ledger is from Perth. So you see this remarkable coincidence. Like, look at the pattern. It's nearly identical. Goes up as well. I've flipped the scale, but it still stands. And my background is in applied statistics. So I can run some tests. I can run statistical tests. I can tell you that, in fact, we have a very strong correlation between those two curves. And that correlation is also highly statistically significant. So what's going on here, right? Obviously, this is a problem with global warming, because we're all doomed and productivity is going to go downhill from here on. So obviously this is tongue in cheek. So let me tell you what the issues here really are and why we're talking about this. So next slide, please. So the two issues here, the two fallacies that I've committed are summarized here. Spurious correlation. I've just given you two completely unrelated quantities that look similar, and they exhibit similar trends and patterns, but they have absolutely nothing to do with each other. Fallacy one. Fallacy two is causation. I said weather drives developer productivity, right? That link is obviously wrong, and it's the old adage that correlation does not imply causation. The reason why we're talking about this is, and we've heard about this yesterday a lot, and I love it because it really shows the problem here. Understanding developer productivity is a hard problem. It's difficult. How do we measure? What do we measure? That's what we want to talk to you about today in the next 20 minutes. So let me give you a quick overview of what we're going to do in the next sort of 20 odd minutes. We're going to give you an overview beyond what you've already heard yesterday here on stage from our Atlassian colleagues on what the developer productivity space is at Atlassian. We're going to introduce you to a fundamental concept, that of vital signs, which is our framework of how we measure developer productivity. And then we'll follow this with a breakdown of how we take these insights, what we learn from measuring developer productivity, back to the engineer, back to the devs. And then we'll finish off with one of our big success stories that sort of like is a continuation of something you've already heard if you were in this session here from our colleagues. We call it Project Sonic. It's all around making, understanding and making work around our PR loop better. So with that, Rebecca, please tell us about DevProd at Atlassian.
Yes. So you heard Dr. Story this morning talk a little bit about happiness and productivity, right? This is a fundamental belief within Atlassian. We believe that happy developers are productive ones, right? So this is effectively a bet that our CTO made that joy will unlock productivity. So if you could think about it, it makes sense, right? Like if I'm having to deal with a bunch of toil every day and just absolute shit code, I'm going to have a bad time, right? It's okay that I said the S word. Okay. I saw somebody jump a little bit when I did it, so I just want to make sure. Similarly, right, if you have a very frictionless experience, you can get into that nirvana of flow, and things are just moving very quickly. Things feel very good. I get a lot of satisfaction out of my focus time when I have it, right? I'm sure you do too. So this is a bet that we're making, and we want to make our developers happy. And the way that we want to make them happy is by removing friction from their day-to-day. So our approach is effectively kind of 3 pillars. When we think about developer productivity, we really believe that developer productivity is socio-technical. Socio-technical. So you see this pillar up here that talks about awesome tools. Of course, we want to build better tools for our developers. We want to have better support for our tech stacks and improve all of the, instrumentation and the tooling and all the technical details of their day-to-day. But we also are teams who work together, right? So there's a lot of cultural aspects that come into this when it comes to driving productivity. Effectively, every productivity improvement we want to make is a cultural change of some sort, of getting teams to do something in a slightly different way, or think about data that we present to them in a slightly different way. And when we first started the program, this idea of empowering teams was very, very, very important. And it still is. It's probably one of the most important things that we do, is make sure that our teams feel that when we identify friction and we put this data and these insights in front of them, that they can go, I'm now going to go spend 10 or 12% of my team's capacity fixing that. And that is part of our planning cycle. We quite literally every quarter go, hey, Tom, what are you prioritizing for productivity this quarter? Right. And when we think about this culture change aspect, within Atlassian, we try to be very, very data-driven, right? We try to provide you the data that you need to understand where your bottlenecks and your inefficiencies are within your team's process and development lifecycle. And we want to not just provide data, we want to provide insights as to how to interpret that data and how to take action from it. So effectively, what we want to do is trap you in a bit of a virtuous loop, right? Where you go, okay, there's some insights about something to do with my project that I'm working on. Okay, let me explore this a little bit further. Okay, I'm now seeing what the underlying causes of this are. Fantastic. Also, here's recommended ways for me to remove these bottlenecks or remove this friction. And over time, I should see whatever this vital sign is that I'm trying to improve. And that feels great, right? When you see things improving over time. So then what do we want you to do? Go find the next bottleneck and fix that, right? And stay in this virtuous loop. So let's get into how do we do this? Starting with vital signs. So vital signs for us represent what we think of as a diagnostic toolkit. And we have a bunch of metrics and measures and things that we're looking at. But the reason we're looking at these metrics and measures is to understand, again, where the friction exists. So we use this to effectively identify and diagnose what the problems are. And when we think about vital signs, they're really focused a lot on the inputs of software development, okay? And because ultimately what we want to be able to do is answer questions. How much time does Rebecca have to code every week? How good are our developer tools? How long does it take for me to get my changes peer reviewed? How easy is it for me to find documentation when I need it? I want to be able to answer all of these questions, and this is what our vital signs help us do. But as we've heard all week so far, well, I guess just yesterday, it feels like all week. It's like a lot of socializing for me. I'm up here like pretending to be an extrovert for you. There's a lot of dimensions that affect developer productivity, right? Productivity is how fast we can move, but how fast we can move is really dictated by the experience itself, right? So when we think about the experience, well, we might just start with, well, what tech stack am I using? Can I find the right documentation for the libraries? But there's a lot more to it, right? Because we want our vital signs to really capture that day in the life or that week in the life of a developer. And there's so many factors. My team process, such as sprint planning. Did I get enough focus time, right? Can I find the information I'm looking for? Is my remote dev environment jittery, right? Like all of these things. Kyle took forever to review my code, right? These all affect me. And we want to gather as many signals as we possibly can across as many dimensions of the developer experience to be able to have this really kind of holistic 360 view of what our developers are facing on a daily basis. So what do? We measure it, right? We can measure all these things, can't we, Maurits?
Love the question. Really, really easy question to ask. So actually, let me bring it back to a lot of the things we've heard yesterday, because I love this framework. Let me try and break down the question. I think the challenges here is, what do we measure? And we've heard a lot about this yesterday. We've learned you can't just go and measure one thing. I think we all agree on that. You need to measure multiple dimensions. All right, okay, fine. What do we know? How do we know what's important? And, we all, we heard a lot about cohorting and about, there's no one size fits all. There's no universal truth. I think somebody mentioned that yesterday. And so it's another aspect of this difficult question. And the third one, and that is the one in a way that I think we haven't heard a lot about, is what about all this variability and uncertainty that we get when we measure all that shit? Apologies.
I started it.
You started it.
Yeah.
So that is something that I think I would like to talk to you a bit more about today, because it's new. It goes a bit beyond what we've already heard. And if we go to the next slide, there's one point that I can't emphasize enough, and I don't get tired about emphasizing this, is that developer productivity, understanding developer productivity, is first and foremost a measurement problem. And any measurement problem of any real world data requires expertise, domain expertise. And that domain expertise comes from data science. It comes from statistics. And I love this talk earlier. I don't know if you've seen it. If you didn't, you should definitely see the recording by Meta earlier today on the partnership that we need to have between data science and engineers. Like, I'm a data scientist. I wouldn't go and write code. Like, shouldn't trust me writing code. And the same goes the other way around. Like, software engineers are not very good with understanding, modeling, characterizing data, right? And so it needs to be a partnership. This is fantastic. We're in this fantastic position where we're talking to behavioral scientists, we're talking to data scientists, we're talking to engineers, and we all need to come together. So what I would like to do in the next sort of couple of slides is take you on a bit of a detour on DevProd from a data science perspective. And don't worry about it. It's not going to be like a statistics lecture. You don't need any super special skills.
It is going to be a statistics
lecture. It is going to be a statistics lecture. But all you need is really summarized by this fine gentleman here, which is your friendly resident data scientist. Imagine him. And the only skill that you're going to need to understand what I'm trying to tell you in the next couple of slides is the ability to extrapolate. You can't actually read it on this one, but you can read it on the higher resolution slides. Extrapolate. Look at a cloud of points and try to identify a trend. Keep that in mind, because I'm coming back to this. So back to, now that I've set the scene, back to what Rebecca left you with, vital signs and all the dimensions we want to measure. How do we do that at Atlassian? We basically measure two different things in two different buckets, two different categories: quantitative signals, qualitative signals. We've heard different terms for them. People call them objective and subjective signals. You can think of them as data that comes from systems, in our case, or software, in our case, Confluence, Jira, Bitbucket. And we have qualitative signals, right, which come from humans, in our case, often, and in most of the cases, surveys, right? And the thing that I want to emphasize here is that one is not better than the other. They are completely complementary to each other, and we are capturing signals, data signals from both. Right? So that's ingredient, if you like, number one. Ingredient two is you need a structure. You need some form of design consideration around these signals. And what I mean by that is you need to understand what the underlying trait, dimension, theme, topic, whatever you want to call it, what that is, right? And I don't care what kind of framework. We have multiple frameworks around that people have adopted to help you with defining what a good signal, what a good metric is. We think Google's goal signals metrics framework, or which is really, in essence, a very basic sort of a design that you have everywhere in statistics. And it's a hierarchical model, right? You have an underlying trait that you want to characterize. You know what you would like to measure, and then unfortunately you need to look at what you can actually measure. That's all there is to it. As long as you have that in your mind, you're good. So let me give you an example of one of the dimensions that we are actually that we're measuring with these two different sort of signal categories that I've just mentioned. So code review, one of the big dimensions, right? One of the big themes. And I'm just listing a few. This is not even a full exhaustive list, but we're looking at PR cycle time. We've heard a lot about this. We've heard a lot about this from our colleagues yesterday. We're looking at the time it takes to review a pull request. We're looking at PR complexity. We heard yesterday about PR complexity, one of the data signals. And then we're complementing this with qualitative data signals, which we collect through surveys. We're running a quarterly surveys with all our engineers. We're asking them, what is your perception of how much time it takes for your code to be reviewed? And do you think this process inherently produces a high quality code? So if we bring this back to Rebecca's beautiful visualization of all the dimensions, it's just this, right? This is one of the dimensions that we're looking at, and we're measuring all these data signals. So,
but that's a lot, right? Wouldn't that be pretty noisy?
So there is, yeah, you're absolutely right. There is like all of these data signals. I think Rebecca mentioned we have tens, 40, 50, and so on data signals covering this entire landscape of dimensions. All of these measurements are going to be noisy. And I mean, noisy is a bit of is a term that is being used very liberally. And I want to, like, in the spirit of, continuing onwards with this statistics foray, let me tell you what I actually mean by noise and what it means for measuring developer productivity. So noise really means a measurement. Anything that I measure has uncertainty, and uncertainty relates to variability. So that's the link. Noise, uncertainty, variability. To make matters worse, in a way, there are two different types of uncertainty of everything you measure. Anything you measure, you have two different types. You have what we call stochastic uncertainty, which means you measure the same thing twice, you get a different value, even if nothing has changed. That is a concept that is surprisingly difficult for some people to accept, but that's the nature of it. The second thing is epistemic uncertainty. It's big words, but it's actually very simple. It means measurement error. It means you're measuring something that is maybe a proxy of what you actually want to measure, and so it's a bit off, right? Epistemic uncertainty is something you can control with your design. You can try and minimize it. Stochastic uncertainty, forget about it. You can't control it in the sense that you cannot eliminate it. You can account for it. You can try and understand it. You can model it. You can build it into your models, but you cannot eliminate it. And this is again where we need to emphasize that to do a good job, here, you need to get the knowledge and the experience of data scientists to help you with understanding, modeling, and accounting for these kind of things. So remember the weather in Perth, right? There are more challenges with this. And the thing I want to point out here, so let me set the scene. Everyone loves summary statistics. Well, I guess so, because we're using them a lot. Think OKRs, right? Who doesn't have OKRs in some way that we're tracking, that we're measuring ourselves against a certain mean, median, percentile, quantile target value that we're tracking month on month or quarter on quarter? What is the issue with summary statistics? So have you heard of the datasaurus? And I love this example because it is actually very close to the software development industry. The datasaurus. Can I show a show of hands, actually? Who has heard of the datasaurus? Awesome. So the datasaurus, it's an amazing and really entertaining paper that was published a couple of years ago by two employees from a company called Autodesk at a conference. And what they're demonstrating is that there can be data sets that have the same summary statistics. So if you just calculate a mean, or you calculate some variability, some variance, standard deviation, you calculate some correlation, those values will be the same, but the underlying data will look completely different, to the point that it looks like a bloody dinosaur. Now, you translate this to OKRs that you measure and track month on month. You might report the same value. It's like, oh, hey, great. A value doesn't change. Median, percentile, quantile, whatever I'm using, is the same, fantastic. We're doing really well, or it's, But in fact, the underlying data is completely and vastly different. So again, this is my example of saying, go and talk, engage your data scientists to help them prevent these pitfalls when you're using summary statistics to track performance or OKRs and so on. One last example I've got. I'm calling this trend spotting, and this is where I need your help. So I'm showing you here a cloud of points, a scatter plot, and I'm going to need your expertise in extrapolating, as I said in the beginning when I showed you the picture of the friendly gentleman with the t-shirt. So I'm not going to tell you what I'm showing you on the X and Y plot, but just have a look at this cloud of points and now extrapolate. In your mind, draw a line. Like, what kind of trend are we seeing here by just looking at this cloud? And I'm going to make this an exercise again with like a show of hands. So who thinks that there is an upwards trend? So there's a trend that goes up of the clouds. All right, good. And who thinks there's a downwards trend? All right, and who thinks there's no trend at all? All right, okay, good. It is a tricky one. It is difficult. There is a lot of variability and a lot of noise, but fortunately, I can just run a bit of code and produce a nice, smooth regression line for you with some beautiful confidence intervals. And this is how it is. There's a straight line with a positive slope, goes up, and I can tell you it's statistically significant, whatever, confirmation you need, quantitative evidence, we're all good. Green. It's all good. Now, what if I tell you that actually what I'm showing you here on the axis is PR cycle time versus developer satisfaction, which we've had, this is synonymous for productivity, as we've had earlier in one of the talks. So what I'm seeing here is developer productivity goes up the longer it takes for a PR to be completed. This is real data. I'm not making this shit up.
It's true, right? We all believe this. No? Okay.
Well, that's, we can just all go, like engineers can take a hike, can go for a little mini holiday and, go on a coffee break and, PR's productivity is going to go up. That's what the data tells you. So obviously, again, this is my last sort of tongue-in-cheek bit for this presentation. Obviously, something is wrong. Let me tell you that what we're looking at actually here is we're looking at two different cohorts. We're looking at two different teams working on two different repositories. And I have color-coded them now as team yellow and team purple, team blue. And now let's do that exercise again. Let's have a look at the trend. And I'm just going to save you the hassle here of having to raise your hands, and I'm just going to show you the results. And this is how it looks. Again, we have two lines, but this time it's the complete opposite of what I've shown you before. The trend goes down. And okay, we can argue about the purple one. There's a subtle trend here, but it's very noticeable, obviously, for team yellow. It's a very strong downwards trend, which, Rebecca, you should be very happy. It's exactly what we would want to see. Productivity goes down as the duration of a PR to be closed, it gets longer and longer. I love this example because this is an example of one of the most famous statistical paradoxes, and it's called the Simpson paradox, and it has to do with cohorting. And again, this is my point to demonstrate that you need to go and talk to the right people when you're collecting measurements to make sense of the data, because you might draw incredibly wrong conclusions if you don't understand your data. So I'm going to leave you with this last slide, and then I'm going to hand it over to Rebecca again. So two things I want to emphasize here. When you're thinking about what to measure, vital signs, metrics, however you want to call it, what should be the kind of design considerations here? And we're calling these like minimal design considerations because they're really fundamental and primal. So it should be meaningful and relevant. Obviously, don't measure what is not relevant to the problem that you're trying to solve. It should be measurable. Obviously, that seems to be trivial. But there's a subtlety to it. It doesn't necessarily need to be measurable directly as long as it's estimatable. And this comes back to where we heard a lot already about modeling data. You need to be able to estimate. It could be an index. Like today we heard from Arby about a new developer experience index. It could be something like this. It's important that it is estimatable or measurable because you need to baseline it. You need to do extrapolations. You need to do predictions. And it needs to be something that can be changed by the business or by the team. Don't go and measure something that you can't fix or can't control. That's one. Second one, how do we then go from vital signs and metrics that you've created to insights? And this is where I'm going to keep it relatively short because I love that we heard about this now so much. Model the data. Understand the data generating process. Model the data. Test your model. Validate your model. There's this beautiful quote that I don't think I've ever seen being referenced so often as in the last couple of days. I'm also wrong, but some are useful by George Box. Yesterday, when we saw these quotes come up left, right, and center, so I felt the need to come up with another quote. So I'm going to leave you with this other quote, which is by another statistician called Donald Wheeler, who is the godfather of statistical process and quality control. And he says something very similar, but it is particularly relevant to our approach. Before we can improve any system, we must understand how the inputs, vital signs, affect the outputs, developer productivity of the systems. And that is the same thing. How the inputs affect the outputs, model your data. So I've told you about the pitfalls of measuring data. I think we seem to reach a consensus that we need to get scientists involved, behavioral scientists, data scientists, statisticians. How do we go, Rebecca? You tell me how we go and bring these insights back to our engineers.
So we have something called our 5R framework. So once Maurits does all of his magic and tells me this is what the problems are, how do we deliver this back to the developers so that way they can now identify where those friction or inefficiencies exist within their software development lifecycle? So we think of our 5Rs really as kind of our distribution, if you will. So again, with this idea, we want to empower teams with these data and insights. So how do we do this? First is we need to provide the right insight to the right person at the right time in the right place to do the right thing. So effectively what I'm describing here is it doesn't just stop with data and insights. We effectively need to build a flywheel of sorts to make sure that our developers are having access to these insights, and these insights also provide ways for them to improve. So first thing is the right insight, right? So we want to provide the necessary data and insights back to those teams to help them improve their own effectiveness. But the important thing here is, again, we don't want to just put a bunch of numbers or a bunch of plots or a bunch of things in front of you and go figure it out, right? We want to help you interpret this data and understand how to use it. Our goal, effectively, is the opposite of this, right? We don't want to flood our developers with a bajillion metrics, even though Maurits and I have a bajillion metrics, right? We want to present the right vital sign in front of them that will help them improve their productivity the most. We don't go, here's 50 different things you're doing wrong. We go, here's 1 or 2 things you really need to be focusing on, okay? And these insights are very specific based off of the context, right? We need to be able to deliver these to the right person. And I don't know about you, but within Atlassian, we have a lot of variation within our teams and within our tech stacks and our tools. So we need to be able to effectively target who we want to receive these insights. And we need to do that really well, because we don't want people to ever wonder, does this apply to me? Because if they're wondering, does this apply to me? Then they're already not trusting the data and the insights, right? And this is challenging, right? This idea of cohorting, right? There's a lot of aspects to it, because it's not just, are you a Java developer or a Node developer? It's not just, are you mobile or front end? It's not just, are you working on product or platform, right? There's a lot more to it than that. And so we need to effectively understand all of these different relationships between, these builds, or they're getting worse. Who is that? How do we give them that information to help them improve their builds, right? So we need to be able to map and attribute all of these different metadata back to the right person to be able to accurately target them with that right insight. And we want this insight to be strategically situated to drive change. We call this an intervention. Maybe not the most PC thing to call it, but that's effectively what we're doing, right? We're intervening at a particular point in time and going, hey, here's data, here's insights, maybe try this instead, right? And so when we think about timing, apologies, it's a bit of an eye chart. It's all about what phase, effectively, of the software development lifecycle we should be raising these insights to teams. Is it during that inner loop? Is it during outer loop? Is it actually during planning or retrospective periods, right? Those are questions that we need to ask. And this idea of right time is intrinsically related to the right place, right? We want to not only put these data and insights in front of people, but we also want to do it non-disruptively. The last thing I want to do is take you out of flow, right? The goal is actually to keep you in flow by helping you remove the friction. So depending on what phase of the software development lifecycle we want to deliver these insights, we need to figure out where or what mechanism puts that insight in front of the developer. And the important thing here is we want to meet the developers where they're working. We don't want to introduce yet another place or yet another tool or yet another thing that they have to think about. So we have different tooling that already exists today. We have different things that already exist within our software development lifecycle. So our goal is to use that, right? Ultimately to surface our different insights to them. Is this something that we can push within their development environment? Is this something that we can give to them in an automated framework that allows them to automatically get onto that paved path, right? Is this something that we surface much later as part of the retrospective periods where they're looking at their service operations and trying to identify actions to improve? And ultimately, our goal is to help developers do the right thing, right? To achieve positive outcomes is ultimately what this idea of the right thing is. So we need to make sure that the practices that we recommend are positively correlated with the outcome that we're trying to achieve. Whoops, that's the wrong slide button. So the other part of doing the right thing, like I mentioned, is making sure that we have recommendations. So this is a really kind of cheesy example here, but it illustrates the point, right? I don't want to just go, hey, Marcus, your PR cycle sucks, right? I want to go, hey, Marcus, we noticed that you're having a slowed PR cycle, and we noticed that very specifically, it's happening at this particular stage of the PR cycle when you're waiting for the review. That's the slowdown right there. And by the way, we have some very specific recommendations for how you can improve. Here we have two, right? I went ahead and just went to the bot one because everybody can understand the idea of nudging. But we're recommending this use of this bot, right? A team should not get this recommendation if they're already using the bot, right? Again, otherwise, they're losing trust in the insight. I'm already doing that. We need to know that you're already doing that and keep providing fresh insights or recommendations to help you do that right thing. So to wrap this up, let me give you a very specific example. Hope I don't get a cease and desist. So we had something called Project Sonic. So we use a lot of kind of project code names. And so about 2 years ago, we endeavored to improve our PR cycle, right? We wanted to have supersonic, see what I did there? Cycle times. We knew that this was a bottleneck, okay? We didn't have, at that time, a lot of data or insights to tell you that it was a bottleneck. We had very poor visibility of our software development lifecycle. We didn't have a huge amount of instrumentation. That's something that we really had to invest in to be able to even collect the data, to even analyze it, to even get to where we are today. And because we didn't have a lot of data or information about what was happening, that resulted in very long feedback loops that our developers were experiencing. And they were telling us this in our surveys. They were telling us this when we would interview them and ask, where does it hurt in the software development lifecycle? They go, right there. Right? So we knew PR cycle was something that we needed to prioritize. But PR cycle is big. There's a lot going on, right? So when we first looked at this, we effectively developed this like top line, if you will, kind of level 0 business metric around PR cycle and release time. So this is effectively measuring the entire outer dev loop from the time that I push and raise my pull request all the way to the time that it's released to production. So then we look at this and we go, okay, that's huge. Let's break that down even further. We have the PR loop itself, and then we have release time. Okay, well, even within the PR loop, there's still a lot going on. So we want to get more and more granular with our metrics so that way we can really pinpoint, diagnose where that friction exists. So we spent quite a lot of time looking at data, figuring out what were the right metrics, what are the right kind of lines to draw, if you will, between these different kind of micro metrics and micro phases that were happening as part of the software development lifecycle. And then once we had a lot of this data, then we started being able to see trends. We started to be able to analyze it, right? I threw Maurits at the problem and I said, data, figure it out. Because he said the engineers were bad with data, right? So what we found was that not all developers, not all teams were experiencing bottlenecks in the PR cycle. So what do? We went and identified those high-performing teams. We figured out what the heck are you doing that makes you so good? And we harvested those practices. We figured out ways to generalize them or contextualize them to the different cohorts that we wanted to target. And then we figured out ways to effectively embed those practices in areas where developers are already working to try and spread, right, the use of those practices. So when we think about this idea of harvesting practices, is all about identifying and then embedding and spreading, which sounds like a communicable disease a little bit there, but interventions, communicable diseases, that's what we're all about here. All joking aside, right? So I'm showing you just one screenshot. It's just one little piece of this, right? But the next thing was like, where do we intervene? Where are the right places to deliver these different practices, these different insights? Well, we knew that there were key pain points around the PR cycle, right? And around the PR loop. We knew that it was taking so long, so people were task switching out. We knew that PR comments were really kind of hard to find and easily missed. We knew that it was really difficult to understand what changes had been made in PRs when it was going in cycles back and forth between the reviewer and the author. And so we really took a step back and looked at our entire PR flow, and we made some enhancements, right? We effectively revamped the UX for our code review experience within Bitbucket. And we introduced features like syntax highlighting, resolvable comments, amongst many other things. But then we also looked at those good practices, and we took it apart and we went, who all is involved in this loop? The reviewer and the author, right? So we came up with a set of like, what are the guidelines that we want our authors to follow, right? To keep things kind of standard, and the more standard it is, the faster it'll go, because it's all kind of becomes a bit of a, I'm going to say production line here, I apologize. And then you also have that reviewer. What should they be looking for? What are the best practices? So this is an example of, it's kind of hard to see, but down in the bottom right hand over here, there's a little app inside your code review experience. So when you're reviewing it, you can go, oh, I want to make sure I'm following the comment taxonomy and calling this a nit or calling this an issue. What is the exact verbiage I should be using? And it's right there for you as part of that experience. So in summary, when we think about it, and this is just, one piece of what we've been working on over the last few years, to really focus on kind of the PR cycle, but it shows that we were able to empower teams with data, help them do the right thing, and ultimately achieve very positive results. So this is one example of some of the cultural changes that we've been making within Atlassian to help our developers improve their own experience and ultimately their own productivity. So as a result, not only were we empowering them with data, we saw an over 50% decrease in the length of time spent in code review. Pretty amazing, right? Over, I think that was 18 months, we saw that much of a decrease. And as of last week, when we did our most recent survey, it still stands that code review is the category in our DSAT survey that has the highest sentiment because of some of the work that we've been doing. So we see this both quantitatively and qualitatively, which I think really demonstrates that data-driven culture change that we've been making within Atlassian. And with that, the lecture is over from the doctor.